our next lesson is about solving problems using graphs. We like to show you how to use the graphs to solve problems before we actually talk about acceleration and kinematics, because you can get the idea of what does acceleration look like before actually working with it. So our learning target is I will learn how to interpret and use motion graphs such as position time, velocity time, and acceleration time to analyze motion and solve problems in various real-world contexts, including physics, engineering, and everyday life. Okay, for this lesson, we're only going to use graphs to solve our problems. Okay, so starting off, there are three main types of graphs. There's the position time, which you should be familiar with. The velocity versus time looks similar to the position versus time. You just have velocity on the y-axis. And then acceleration versus time. Again, very similar to the other two. It's just that acceleration would be on the y-axis. Okay. There are two major parts of a graph that we're going to use to solve the problems. The first one is the slope. Okay, so if you remember, the slope is how steep does the line on the graph, how steep is it? So it's like, so you take the rise or fall on the x-axis of the graph line divided by the run. So how far over does it go? Okay. The second one is the area under the graph line. Okay. And we're going to be working with some simple shapes. You have a square or a rectangle, which is the area is base times height. And then there'll be some triangles, and those are 1/2 the base times height. Okay, so it's really important that you put this into your notes, okay, the entire table. So this particular table gives you everything that you need to know about constant motion. And constant motion happens when the velocity stays the same and there's no acceleration. Okay, so here are three different types of graphs. These are the shapes that they would be. On a position versus time graph, you would have some sort of sloped line. On a velocity time graph, you would have a horizontal line. And on your acceleration versus time graph, there would be a horizontal line at 0 because there won't be any acceleration. So on our distance versus time graph, if we look at the slope of the line, we get the velocity or the speed of the object. Okay. The area doesn't tell us anything. When you look at the velocity versus time graph, you can see that the velocity is constant. So the velocity here doesn't change. If we look at the area, right, the box below the line, that is going to tell us how much distance we've changed. It doesn't tell you exactly where you are. It just tells you the distance that you traveled from time A to time B. Okay? Okay. So now with accelerated motion happens when the speed changes. Okay? So if we're looking at a velocity time graph, you can see that the velocity is changing as time goes, right? It can go up, it can go down, which means speeding up, slowing down. The position time graph is a parabola or half of a parabola, okay? So it's got that curve to it, okay? And then the acceleration time graph, the acceleration then is a horizontal line, usually above or below 0, okay? So on your distance time graph, remember the slope was the velocity? Well, this is still the velocity, but when you're looking at the slope of the line, you're looking at the tangential slope, right? So a line tangent to or just hitting one of the dots of the line, that is your instantaneous velocity. Okay. Again, you're still going to use rise over run. Okay. On a velocity time graph, that slope tells you the acceleration. Okay. And then again, the distance is also going to tell you the change, or I'm sorry, the area is going to tell you the change in the distance. Okay. Now we have our acceleration graph, and basically this is saying that acceleration stays the same, right? So the acceleration is constant in terms of the slope, but the area under the graph tells you how much the speed changed, right? It doesn't tell you the exact speed, but it tells you how much it changed. Okay. Okay. So when you're solving these problems, the first thing you want to do is determine what you're given for information, right? Are you given distances? Are you given positions? Okay. Or are you given velocities, or are you given accelerations, right? Then sketch the appropriate graph. Now, it says sketch. It doesn't say, make out a grid and all that kind of stuff. You just have to kind of sketch it out a little bit. Okay. So if you're given velocities, then you should use a velocity time graph. If you're given acceleration, you should draw an acceleration time graph. If you're given position, then you should draw a position time graph. And then the next step would be to determine what the problem is asking you to solve, right? Is it asking you to solve for something that you would need the slope, or is it asking you to solve for something that you need the area for? Okay. And then refer back to your notes to figure out which one you would need for the question. So here's an example. Juana Dance pedaled his bicycle from rest to a speed of 15 meters per second in 3 seconds. Then glides at that speed for 2 seconds. Okay, so what we're given is we're given that the beginning speed is 0, right? That's this word rest, starting from rest. So we start at 0 meters per second. And then it says that we go up to 15 meters per second. That's our ending velocity. Our first time is 3 seconds, and our second time is 2 seconds. Okay, so looking at this, I would draw a line that starts at 0, and then just mark someplace on here where 15 meters per second would be. Okay, and then that line will go up to wherever your 3 second mark is, right? So now we have a velocity time graph that has an increasing velocity. Okay. And then it says that it glides at that speed for 2 seconds. So it stays at 15 meters per second for 2 seconds, right? So the next time should be 5. Now, if you notice, my graph is not perfect, right? My 3 seconds is definitely shorter than my 2 seconds in between the 3 and the 5. That's okay, because you want to give yourself a visualization of what's going on. And if you try to cram it all into some tiny little graph, you won't be able to see what it is that's going on. Okay, Then part B asks what was his average acceleration. So remember from our grid here, right? Our notes, it says to find acceleration, find the slope of the velocity time graph. So if I go back, here is my velocity time graph. Remember, slope is the rise over the run, right? So it would be 15 meters per second divided by 3 seconds. Okay, that's going to be equal to 5 meters per second per second. You can write it as meters per second squared, but Schoology isn't really good at using things that say squared. So I always just do meters per second per second. Okay. How far did he travel? Again, if we go back up, I want to know what the change in the distance is, right? So I'm going to follow that over, and that's going to tell me that that is the area. Okay. So I'm going to look at my area on my graph. Okay. So for the first part here, right, you can see that there is a triangle. Okay. And for the second part, you can see that there's a rectangle. Okay. So the first part is the triangle, which is 1/2 the base times the height. Then we're going to add in our rectangle, which is 2 times this is the base, this is the height. So this is 2 times 15. And then put those together, you get 52.5 meters. So from here all the way up to here is 52.5 meters, and still in 5 seconds. Okay. So when it asks you to sketch an X versus T and an A versus T graph, A versus T is always just going to be straight lines. Okay. They're always going to be horizontal bars. They're never going to be slanted or any of that kind of thing. Okay. And then the X versus T, or the position versus time graph, if it's accelerating, you're going to have a parabola. If it's speeding up, the parabola is going to go this way. If it's slowing down, the parabola is going to go this way. Okay. And then on that second part, the velocity stayed the same. So from here to here is our 3 seconds. And then from here to here is the constant motion. Okay. Remember, during constant motion, there's no acceleration. So that would be on the 0 line. And then during this time, right here, your acceleration is 5 meters per second. So this would be a 5 right here. Okay. Okay, so let's review. Okay, so there's 3 main types of graphs: position, velocity, or acceleration. Never all 3 on the same one. The 2 major parts are slope and area. The constant motion means there's no acceleration. Okay, and then on the position time graph, you have the slope is velocity. On a velocity time graph, the area is the change in distance. Okay. When something is accelerating, right, your position time graph is a parabola. Okay. The slope is still the velocity. Okay. On the velocity time graph, you have the acceleration is the slope. Change in distance is still the area under the graph. It's just now we have a triangle. Okay. Your acceleration is constant, so it's going to be a horizontal line wherever the acceleration happens to fall. And then the area under that graph gives us the change in speed. Okay. All right.